Hello, and welcome back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 680, Valid Palindrome II. Let's read the question prompt. Given a string S, return true if the string can be a palindrome after deleting at most one character from it. Let's look at some of the examples. Here, if we're given A, B, C, A, we should return true. Why? Because we could delete the character C. We could also delete the character B, and we would still have valid palindrome. So if we deleted C, we would have ABA, which is a valid palindrome, or if we deleted character B, we could have CA, right, which is also a valid palindrome. Now let's look at this example. We're given ABC. Nothing here we can remove will give us a valid palindrome. So let's see why. Well, if we remove the A, then we would be left with BC. Obviously, this is not a palindrome. If we remove the B, we'll be left with AC, which obviously isn't a valid palindrome. And if we remove the C, we'll be left with AB, which is not a valid palindrome. So we can see how they got false here. Now, let's think about how we might solve this problem. Now that we've read the question prompt and we've looked at some examples, let's figure out how we're going to solve this problem. Before we dive right in, let's remember that a palindrome can be a string that is either odd length or even length. So for example, if we had the string ABA, this is a palindrome because the B is on its own, but the A is matched, right? So this is a valid palindrome. Now let's think about if we have an even string, right? For it to be a palindrome, then the middle characters, these B's, would have to mirror each other, and then obviously the A's would match. So we know that that's the case when we have an odd or an even palindrome. So we need to keep that in mind for when we're solving this problem. Now, let's think about how we might do this. If you remember how we solved Valid Palindrome 1, Valid Palindrome 2 is going to be very similar. We're going to have a pointer I starting at the beginning of the array, and we're going to have a pointer J at the end of the array. And actually, let me write arrows here to indicate where we are. So this is where I is going to be in the beginning, and this is where J is going to be. So what we want to do is we want to do the standard palindrome check. So we're going to check, okay, is A equal to A? Yes, it is. So that means that we're allowed to move our pointers for I up. So now I is going to be pointing at the B, and J is going to be pointing at this B. So we're going to do the check again. Does B equal B? Yes, it does. Cool. So now we can move forward. So we'll move forward. Now we're at D and D. Okay. Does D equal D? Yes, it does. We should do this way. Yes, it does. So we can move forward. Okay, so now we move here and we move here. Okay, does C equal E? No. So this is our first point of divergence, right? So at this point, if we were just looking for a standard palindrome, this wouldn't be it, because we know that, we found a place where the characters don't equal each other, so it's not mirrored, from front to back. But in this question, we're allowed to delete at most one character from it. So what does that mean? If we were to, that means that we can either delete C or we can delete E, and we need to check whether the rest of the string is a palindrome. So up until this point, we know, since we got this far, that up until here is a valid palindrome. So we're only concerned with whether the rest of this string can be made into a valid palindrome by deleting either this C or this E here. So let's do that. Okay, well, what will happen to the string if we deleted this C here? So let's delete the C and let's check this E. So we have E. And here we're checking for a palindrome. We've already used our one deletion, so we have to make sure that this string here is a valid palindrome. So we'll start the checks again. So we'll start at the beginning and we'll say E and E. Okay, are they the same? Yes, they are. So then we both move here. And in this case, this is an odd length palindrome, so this E on its own is fine. So this is actually a valid palindrome. So if we got rid of the C, then we know that this can be made into a valid palindrome. So this solution, we would actually be able to make it a palindrome because all we have to do is delete the C. So whenever we meet a point where the two letters don't match, then we need to check whether deleting either the one where the I pointer is at or the J pointer is at will make it a valid palindrome, and it's an OR operation. So for example, we could have deleted this E, and then we would have to check, okay, is C, E a valid palindrome? And we would see, okay, C does not match with E, therefore this is not a valid palindrome. But since we're working with an OR operation, we only care about whether deleting one or the other would make it. And remember, we're only allowed to do one, which is why we have the OR. So if one works, we're fine. And if they both work, it doesn't matter. We can remove one or the other, and we know that it's fine. So to recap, what we want to do is we want to do the standard valid palindrome check. So we're going to start at one pointer at the beginning and one pointer at the end, and we're going to keep going until we have a divergence. At that point, we need to check if removing the character that diverged on the left side would make the remaining string up until kind of where our J pointer is at a valid palindrome. If it is, we're done. If not, then we check, okay, what if we remove this character and we check this part of the string? Would that make it a valid palindrome? If it is, then we know that we can remove one character and make the entire thing a valid palindrome. If not, we were not able to. Therefore, this string is not possibly, we could not make it into a valid palindrome by deleting at most one character from it. So if that's a little bit confusing, let's go to the code editor and I'll show you how to implement it in code, and hopefully it should make a little bit more sense. I'll see you there. Okay, we're now in the editor. Let's write the code. The first thing we want to do is actually do a little bit of an edge case check, because we know that any string whose length is less than or equal to 2 will always be a valid palindrome, right? We could have the string like AA, that's always a valid palindrome, or AB, we could have A, and the reason that it's less than or equal to 2 is because we can just remove one character, and if it's length 2, then it will just become a one character length string, and we can just, that's a valid palindrome, right? A one character string is always a palindrome. So we can add that in if len s, and you don't have to do this. This is kind of just showing your interviewer that you've kind of thought about some of the edge cases. It won't really affect much, but if you want to add it, go for it. If you don't worry about it. So we know that we initialize our 2 pointers. So I is going to equal to 0 and j is going to equal to the length of our string -1. And what we're going to do here is we're going to set up our valid palindrome check like we did in Valid Palindrome 1, which is going to be while I is less than j. What we're going to do is we're going to say if s of I, so if the character at the ith index in our string does not equal the character at the jth index of our string, then we need to know, okay, if we remove either the character at the ith index or we remove the character at the jth index, will this string be a valid palindrome? And if it is, then we know that we can remove at most one character from the string and get a palindrome, which is what we're looking for here. So if this is the case where they don't match, then what we want to do is actually return, and we're going to write a function here to just check if a string is a palindrome, which is going to be the standard palindrome check that we wrote in Valid Palindrome 1, except in this case, we don't have to worry about anything, any strange characters. It's just lowercase English letters. There's no spaces, no weird punctuations, none of that. So it's just a very standard check. So at this point, we can return, and we'll write a function for this in a second. So self.is palindrome, and we're going to pass in the string. And remember, we want to chop a character. So we're going to chop from the left side. So we're going to say I +1. So we're going to chop that leftmost character where the ith index is currently pointing, because we want to check if getting rid of it will make us a valid palindrome. And we're going to go up until the jth index, which is where we're at on the right side, or if removing the right side character. So we're going to pass in the string, and this time we're going to say j -1 because we want to chop it at whatever we're pointing at the right, but one index before that, which is going to be j -1, to chop off that right character. If either of those is a valid palindrome, then we can simply return true here because we know that we can remove at most one character, and we're done. And then in our valid palindrome check, we're just going to check for a standard palindrome. We don't have to worry about any sort of like removing characters or anything like that. So that's the case when they don't match. If they do match, then we know that we can move forward in our string for the I pointer, and we can move down the J pointer. And at the end, if we get through the entire string, either this will trip and then we'll return, true or false here, or we got through the entire string, which means that it was a palindrome to begin with, so we can simply return true. Now, let's write our function to actually do the palindrome check. So we're going to say def is palindrome, and we're going to say self. So we're going to take in the string, we're going to take in the I index, and we're going to take in the J index. And what we're going to do is we're going to do the standard palindrome check. This time it's going to be quite simple because it's only lowercase English characters. We don't have to worry about uppercases, punctuation, white space, any of that. So we're going to say while I less than j, we're going to say if string of I does not equal to string of j. So in this case, we're just looking for a palindrome. If they don't equal, we know it's not a palindrome. So we're going to say return false. Otherwise, what we can do is we can increment the I and we can decrement the j, and we can simply return true at the end. So let's submit this and make sure it works. And oops, what is going on here? While len s. Oops. Okay. Yeah, less than or equal to 2. Don't know what I was thinking there. Cool. Okay, it works. So before we go, let's touch on the time and space complexity. So time complexity wise, in the worst case, basically, we're going to have to iterate over the entire string. In the case that it's a valid palindrome to begin with, we're just going to have to touch every single element, and there's nothing we can do about that. Regardless of whether or not we chop characters or not, we're still going to have a linear solution. So it's going to be time is going to be a linear solution, big O of n. Space, we don't actually create any sort of extra arrays, dictionaries, anything like that. We just have 2 pointers here, and we, that's a constant space allocation. So our space complexity is going to be big O of 1. So that's the best that we can do for this problem, is going to be big O of n for the time and big O of 1 for the space. And that's how you solve Valid Palindrome 2. If you enjoyed this video, please like, comment, subscribe, and check out my other videos if you're preparing for on-site interviews. Happy coding!